So what I want to look at actually is you guys have in the shared drive, you have the department graphing review. And so let me pull that up real quick. And by department, I just mean somebody else wrote it, not me. It's just the graphs you guys need to know. All right, so the graphing department handout. Okay, so here it is. Let me share it with you guys so you can see it. But this is in the Unit 2 folder. I think it's in the first part, but anyway, it's here. Oh, no, that's my iPad. My bad. Okay, so these are the ones that you're responsible to know. So we should know the basic graphs of sine, cosine, tangent, inverse tangent, e to the x, log x, 1 over x squared, square root x, cube root x squared, x cubed, probably x to the 4th, x to the 6th, x to the 8th. They all look basically like this. And x to the 5th, x to the 7th, x to the 9th. They all basically look like that. And then we should be able to graph any line, graph any parabolas. And then this is some stuff about shifting. So all right. So the main thing I wanted to talk about though is, okay, if you have one of these base graphs, then how do they get shifted? And then in more detail, what I really want to talk about is how does it change when you do like x equals y squared instead of y equals x squared? Are there any of these 12 that are listed where you don't remember? Completely fine, because I believe the answer to this is yes. Are there some of these where we don't remember what they look like and we'd like to talk about quickly just what the basic shape looks like?
Can you go over?
Go ahead.
Sorry, go ahead.
Like the tangent one and
Tangent. Yep.
Yeah.
Okay, so tangent and inverse tangent.
Yeah.
Okay. Any other ones, you guys?
And the cube root.
Tangent, inverse tangent, cube root. Okay. Any other ones?
About 1 over x squared.
Okay. Yeah. Okay. So let's kind of review some of those. And then if you guys see more, or if you think of more, let me know. Got it on annotate. Give me 1 sec. Sorry, guys. Okay. Okay. We're back to my iPad, right? Can you see that again? All right.
Yep.
Okay. So, well, here, let's just kind of, let's do this. Let's say, okay, I understand nobody asked for this one. Whoops. But you guys all understand that y equals x squared looks like this, right? But so does y equals x to the 4th, y equals x to the 6th, and so on. It just the only one that's technically a parabola is y equals x squared. Y equals x to the 4th and x to the 6th. What happens is it gets steeper on the edges and flatter right in the middle. So like as you go up, it's like real flat from 1 to -1, but then real steep on the edges. But those are basically the same shape. Does everybody see that? Okay, y equals x cubed, x to the 5th are all basically like this. And again, flatter in the middle and steeper on the edges, the higher that power gets. Does that make sense to everybody? Okay, cube roots and square roots are similar to that. So y equals square root of x. Looks basically like that, but so does the 4th root and 6th root. And again, it's like, you know, a little more warped of a picture, probably steeper right at the beginning and then more gradual at the end. But it's basically that. It's actually like the left half of this parabola rotated around. And then cube root is like this. No asymptotes, just very slow at growing on the right and on the left. Does that make sense? But it does go to infinity on the right and left. But the 5th root and 7th root and 9th root and so on look basically like that. They become even more gradual and steeper in the middle and then more gradual, more like that. Okay. All right. Does that make sense to everybody? Okay. Y equals 1 over x is like that. These points, that's 1 and 1 and -1 and -1. Does that make sense to everybody?
We are allowed to use physical notes on the exam, right?
You are. Yes.
Okay, cool.
Not electronic. So you're not allowed to graph this on a graphing calculator, but you can write this down and have this all there.
Okay, thank you. That's what I was
yeah,
curious
sure,
about.
Sure. Or you know what? Let's neaten this up and I can send this as a PDF. Would that help?
That'd be really helpful, actually. Thank you.
Okay, cool. Yeah, no problem. I didn't even think about it. Let's not erase the graph, but let's. Now, you guys, just so we're clear, these are approximate graphs, right? But this is the basic shape. So, you know, I'm not doing them to scale or anything, but this is basically what's going on. Y equals 1 over x cubed and 1 over x to the 5th look basically the same as these. Steeper in places and like a little sharper turn, but like basically the same thing. Does that make sense, everybody? Okay. Y equals 1 over x squared. And 1 over x to the 4th and 1 over x to the 6th. Same thing in the first quadrant. That's 1, 1 again. But then all the squareds and even powers, flip this one to the top. That's supposed to be symmetric. Let's make that a little better looking. And so basically like this part, all the Y values become positive. And so the bigger the power, like the steeper it is in certain places and the sharper the turn in the middle, but it's basically that shape. Does that make sense to everybody? That's good. Asymptote at x equals 0. Horizontal asymptote at y equals 0 on all of those. Okay, so that's those. Later, it's actually going to become important that you have like 1 over this. We won't deal with that. She didn't put it on that list. But 1 over the square root of x, 1 over the cube root of x, you get stuff like these. But we'll talk about that more when we get to improper integrals. Okay, and then somebody had asked tangent. There are asymptotes at odd multiples of pi over 2, meaning at pi over 2 and at 3 pi over 2 and at 5 pi over 2 and so on, but also at negative pi over 2 and at negative 3 pi over 2 and so on. And then in between those, there's an x-intercept right in the middle, so at 0 and at pi. And again, my graph's not to scale. That width, this is exactly the same shape and size as this. Does that make sense? And that repeats forever to the right and to the left. So you just get those over and over and over again in each direction. Does that make sense? Again, my picture is certainly not perfect, but we follow the idea? Okay. Inverse tangent. This is actually a really important graph later for limits. We use this a lot. This one does have asymptotes. So it looks really similar to this picture, but this goes up and down forever to the right and left. So like this goes up to the right forever to positive infinity. This goes down to the left to negative infinity. Inverse tangent looks similar, but it's bounded by asymptotes on either side. So it goes to negative pi over 2 and pi over 2. And it's basically that one piece in the middle of the other graph of tangent flipped on its side. But does not go to negative infinity, approaches pi over 2, negative pi over 2. That's important for limits. So like the limit of that is x goes to infinity is pi over 2. And we know that from the graph. And then the limit of that is x goes to negative pi over 2. I'm sorry, as x goes to negative infinity is negative pi over 2 because of that. Does that make sense, everybody? That's good. Was that it? I think that was all of them. Everybody remember sine and cosine? I think those are the only two we didn't end up actually reviewing. Oh, e to the x and log x. May as well do them. All right. Everybody good? Good. All right. So y equals sine x. It goes through 0, 0, and then everything significant that happens is like, the easy way to think of it is every main thing happens every pi over 2. So like at pi over 2, it goes up to 1. And then it's back to 0, and then it's down to -1, and then it's back to 0. So it like goes like that, and it flips between 0 and 1 and -1 every pi over 2. So like that's negative pi over 2, -1, and then negative pi, 0. And it's a smooth curve, not me shaking my hand, but does everybody follow that? That's good. All right. And y equals cosine. Very similar to sine, except that it's 0, 1 as the y-intercept. So it is up there. And then again, everything, like every main thing happens every pi over 2. So like it goes down to 0 here. It goes to -1 here. It goes back to 0 here. It's 0 at negative pi over 2. And so it's just like nice curve, unlike what I'm drawing, but a nicer curve. My sign picture is a little better, but does that make sense? It just repeats forever. All right, and then y equals e to the x. There's a y-intercept at 1, and then there is a horizontal asymptote that goes forever to the left and continues to go down to the left. Does not actually go up it now, but it looks like that goes up really, really fast on the right. And then y equals natural log x. I don't know why I'm choosing all of a sudden to put arrows on those. But all right, so this is at 1. It's kind of like square root in that it grows real slow on the right, but does go to infinity. But then there's an asymptote where it goes to -infinity near 0 from the right. All right, I think that's all of them that were on that sheet. So we got sine, we got cosine, we got tangent, inverse tangent, e to the x, log x, 1 over x, 1 over x squared, square root, cube root, x squared, x cubed. Yeah. And then any line and any parabola, basically. So I assume we're comfortable with like y equals mx plus b. Is that true? If not, say something or put it in the chat if you're embarrassed. You can put it privately to me. I don't care. I'm not going to judge you for not remembering that. Everybody good though? All right. All right. So then the thing I did want to talk a little bit about in the review was kind of those shapes. But then does everybody remember, like, okay, the thing that I think that people have the most trouble with are the ones where it's x equals. So like being able to graph this is something that is not that hard, but it's not something we're used to doing. Is that true? Like we haven't done that a lot, right? Okay, yeah. So one thing we want to know is that x equals y squared is also a basic graph. So x equals y squared is one that might come up a good bit, and it's one that opens to the right. It's just like y equals x squared, except it opens to the right instead of opens up. And you actually could think of it as y equals plus or minus the square root of x, where this is the square root of x on the top and it's negative square root of x on the bottom. But when it's x equals y squared, it's one equation that describes the whole curve. Here, it's two different equations. It's y equals square root x on the top, y equals negative square root x on the bottom, but you can think of it either way. Does that make sense to everybody? All right, but we want to be able to think of it from x equals y squared. That's very helpful. So does everybody remember that, like, if I have y equals like x minus 5 squared plus 4, that this is shifting to the right 5 and up 4. Does everybody remember that? So it's like y equals x squared, like the basic parabola, and then shifted to the right 5 up 4. Okay, there's there is for sure. If I was teaching an algebra class, there'd be a more detailed explanation as to why this happens. But the basic explanation is that the number here is before the main function. So like the x squared is the main function that's creating the shape of that graph. This -5 is before the shape gets formed, which is basically why it's backward. And so like -5 you would think would be to the left 5, but it's to the right. And it's because it's before you're making the shape with the x squared. So not an entirely accurate explanation. And we could, if we want to talk about it in more detail, we could always do that. But in an algebra, we would do that. But here, basically, you want to think, okay, well, it's before this, so it's backward, and it's affecting x. So it's on the x, which means it's going to affect the x direction, so either left or right. So it's left or right, but backward. Does that make sense? This is after the square, which means it's not backward, and it's not directly affecting x, it's affecting y. Okay, because it's affecting x squared. So because it's affecting y, it's up or down, and because it's after the square, it's normal. Positive is up and negative is down. Does that make sense? Okay, so then if I have one like this, that would start with the basic shape x equals y squared. Well, the -5 is with the y. So that's going to be either up or down. Does that make sense? Okay, so it's affecting y, so it's up or down, but it's before the square, so it's backward. So then -5, what do you think that would do to the graph? So it's affecting y, so it's up or down, but it's before the square, so backward. What do you think?
Raise it 5.
Yeah, it's going to raise it up 5. Does that make sense to everybody? And then, okay, the +4 is after the square, so it's not backward, but it's affecting x. So because it's affecting x, it's left or right, but it's normal. So what should this be? To the left or to the right?
To the right.
To the right. So this is to the right 4. And so this graph would be that one on the left over here, where that, and I should draw it better, but that vertex is to the right 4 and up 5, so 4, 5. Does that make sense? Okay, and so then like ones you see in my examples a lot, I'm going to block this off just because if I do send this out as a PDF, you can see that. So if I ask you guys to graph this as part of a volume problem, then okay, the negative y squared flips it over the y-axis, and you can think of it as negative y squared plus 15. So this flip, and this is to the right 15, just like that. Does that make sense? Yes, good. Now that's not everything ever with graphing, but that covers most of what you're going to have to be able to draw on an area volume problem that's reasonable for a Calc 2 test. So if you want to practice that stuff, you've got a ton of volume handouts. There's one that you actually have to submit on CrowdMark, but then there's 2 more that I'm going back and forth as to what you're going to have to submit next week on that. But volume in area 2 and volume in area 3 are there. So there's a bunch of regions within those practice problems. There's also the graphing review, and let me pull that up real fast. And I've got the graphing review, and then I've got graphing review solutions that are in your shared folder or the shared drive. And so it looks like this, where there's just a bunch of practice ones to do. So like this is kind of like what we were just talking about. And those are some lines and natural log e to the x. So just a bunch of different ones to practice. And, you know, of course you don't have to do this, but you're welcome to do that if you want more practice in figuring out the graphs. And then I've got on there, let me go ahead and open that up too. I've got the full worked out solutions to those. So like, you know, just rough sketches, because that's what you want with volume anyway, but labeling important points like the, you know, where the square root function starts or where the vertex of the parabola is. So that's all I wanted to talk about, was basically how do you shift it when it's X in terms of Y, and then what are the basic shapes that we're having trouble with. Is there anything else you guys have questions on with graphing? Do you guys feel like what I would do is go do as many of those volume problems as you have time for? Definitely don't do calc the whole weekend, but you have a test Thursday, so do calc some this weekend. So go practice those. And then next week, if there's one where you can't figure out the picture, let me know. But you have a ton. There's 3 big handouts on area and volume in the shared drive where you've got a bunch of regions to draw. Okay. All right. If you have last minute questions, stick around. If not, I hope I'll see you guys next week. Have a good weekend. Do start studying some, but go ahead.
Is the only thing that's due Monday the 3 crowd mark assignments?
Yeah. So nothing on WebAssign right now, just the 3 written ones. And those, you guys, just be perfectly honest, it's going to be checking off. You're going to get full credit for having done it. So we're not going to grade those because of the turnaround time for the exam. They're just going to, you get credit for handing it in. So just if you're looking at that and you're not sure how to do something, definitely let me know and let's go over that next week. I'll offer at least 2 review sessions for the exam, so you can come ask questions from that stuff if you want to. Does that sound good? Okay. Other questions? All right, you guys have a good weekend. Enjoy. I'll see you Monday or Tuesday. Monday.
You too. Have a good weekend.
You too. See you later. Thanks, guys.